Inside this plastic disc, there is a tiny amount of radioactive material. It emits ionizing radiation that I cannot see, hear, or sense in any way. While this particular source is comparatively safe, it would be the same for very dangerous ones as well. Hi, I'm Mihai Kuciuc, and in this video we will be discussing about detecting gamma rays. More on that later, but first, do you just have radioactive material lying around? Well, yes and no. On the one hand, there is this thing called background radiation. Radiation that we're constantly exposed to no matter where we are. And the part of that comes from naturally occurring radioactive material, which is everywhere. In the building materials we use, in the ground, and even within ourselves. But this source is much stronger than background radiation, so it needs to be handled properly. We are now in one of the labs at the Extreme Light Infrastructure Nuclear Physics Facility in Romania. There's a link in the description where you can check some of the cool things we do here. This lab is a restricted area, meaning that we are allowed to use radioactive sources because there are strict rules to make sure that it is done safely. In order to detect radiation from this source, we need a device like this one. It senses each gamma ray, converting it into an electrical signal that can then be measured. And it can make a sound while it detects something too.
The simplest measurement is counts per minute, which is just how many gamma rays it detects in a minute. Up until now, the detector was measuring background radiation, about 590 counts per minute. But with the source, this value increases. As I bring the detector closer and closer to the source, the value itself gets higher and higher. Right now, it measures 30 to 40 kilocounts per minute. Now, this is useful to detect that something emits gamma rays, but I still can't tell how dangerous it is. This is because gamma rays can have different energies, and a higher energy one can do more damage than a lower energy gamma ray, but in this mode they both get counted the same. Now the detector is set to measure dose rate, in this case in microsieverts per hour, and we see that background is on the order of 0.1 microsieverts per hour. This measurement mode takes each gamma ray's energy into account to better estimate how dangerous a source is, as it correlates to how much energy is deposited by the radiation in our bodies. We see that if we get really close to this lab source, we measure up to 23 microsieverts per hour. For context, while flying on an airplane at normal cruise altitude, we're exposed to about 3 microsieverts per hour.
While we're discussing radiation detectors, this right here is a dosimeter. It's a passive detector that records all of the radiation I'm exposed to in order to make sure I am performing my work safely. These are required by law for all radiation workers. Can you think of applications that require detecting ionizing radiation? Do all applications you think of also need a radiation source like this one? Let me know in the comments below. Special thanks to the Extreme Light Infrastructure Nuclear Physics Facility for letting us film in the lab, and thank you for watching.